So, let's start with the basics. What exactly is machine learning? You've probably heard the term thrown around a lot, but in simple terms, machine learning is a part of artificial intelligence, AI, where computers can actually learn from data. Instead of you having to write a bunch of specific rules for the computer to follow, machine learning models look at data, find patterns in it, and use those patterns to make decisions or predictions. Example: take email spam detection, for instance. The old school way would be to sit down and write a ton of rules for what spam looks like. Like, if the email contains the word lottery, it's spam. But with machine learning, you don't need to do that. Instead, you give the model lots of examples of spam and non spam emails, and it learns the patterns that make an email likely to be spam. The more examples you give it, the better it gets at catching those annoying spam emails. Now, machine learning isn't just one thing, it comes in a few different flavors. Let's talk about the three main types: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning, the model learns from data that's already labeled. That means for every input, like the size of a house, the correct output, like the price of the house, is already known. The model's job is to learn the relationship between the inputs and outputs so it can predict the output for new data. Imagine you have historical data on house prices. You know the size, location, and number of bedrooms for each house, and you also know the prices. You'd use supervised learning to predict the price of a new house based on its size and other features. In unsupervised learning, there's no labeled data. The model doesn't know what the right answer is, so it has to find patterns or groups on its own. It's kind of like exploring a puzzle without a picture on the box. Let's say you have data about your customers, but no labels telling you who is similar to whom. You could use unsupervised learning to group customers based on their buying habits, like grouping people who tend to buy certain products together. This helps businesses figure out how to target different groups of customers. Reinforcement learning is a bit different. Here, the model learns by trial and error. It takes actions, gets feedback, rewards or penalties, and improves based on that feedback. It's almost like training a pet. You reward good behavior and correct bad behavior. Think about a self-driving car. The car's brain is constantly learning by interacting with the environment. If it follows traffic rules correctly, it gets rewarded, like staying on the road. If it makes mistakes, it gets penalized, like veering off course. Over time, it learns to drive more safely. All right, so why is everyone talking about machine learning? Well, it's because machine learning is changing the game across almost every industry. It's not just some buzzword, it's actually solving problems and making things better in ways that were hard to imagine just a few years ago. Here are a few areas where it's making a huge impact. Healthcare. Imagine a computer looking at medical images like X-rays or MRIs and spotting diseases that even doctors might miss. Machine learning is helping doctors diagnose diseases faster and more accurately. Finance. Banks are using machine learning to catch fraud. It can quickly detect weird patterns in transactions and flag them before any major damage is done. Retail. Ever wonder how online stores know exactly what you want? That's machine learning at work. It analyzes your browsing and buying habits to recommend products you're most likely to buy. Technology. Voice assistants like Siri or Google Assistant, they rely heavily on machine learning to understand what you're saying and respond in a helpful way. And they keep getting smarter the more you use them. The real power of machine learning is that it can automate tasks that are super complex for humans and uncover patterns or insights that we might not even notice on our own. It's basically like having a really smart assistant that keeps learning and getting better at its job. So, how exactly do you build a machine learning model? Let me walk you through the general process. It might sound technical, but once you break it down, it's pretty straightforward. 1. Collect data. Everything starts with data. In fact, the quality of your data is the foundation of your model's success. If your data is solid, your model will have a much better chance of performing well. Let's say you're trying to predict house prices. You'd gather data like the size of the house, the location, the number of bedrooms, and of course, the actual prices of those houses. The more data, the better. 2. Pre-process the data. Now that you have your data, it's time to clean it up. Real world data is messy. There are often missing values, duplicates, or inconsistencies. Pre processing is like tidying up your room before getting to work. For the house price dataset, you'd make sure there are no empty entries for things like house size or price. You'd also ensure that all the data is in a usable format. 3. Choose a model. Next, you need to pick the right algorithm or model to solve your problem. Different models are better suited for different types of tasks, so choosing the right one is key. If you're trying to predict house prices, you might use linear regression, which is great for predicting continuous values like prices. Number 4, train the model now. This is where the magic happens. You feed the data into your model, and it starts learning the relationships between the inputs, like the size of the house, and the output, the price. The model is basically figuring out how these factors are connected. Room 5, evaluate the model. Once the model is trained, it's time to see how well it performs on new, unseen data. This step is crucial because you want to ensure that your model can make accurate predictions on data it hasn't seen before, not just the data it was trained on. 6. Tuning and improvement. Finally, if your model isn't performing as well as you'd like, you can tweak a few things. You might adjust parameters, add more data, or even try a different model altogether to get better results. This step is all about making those fine-tuned adjustments to optimize performance. All right, let's look at a simple code example that uses linear regression to predict house prices. We'll use Python and the scikit-learn library, which makes things pretty straightforward. Let's break it down. What are we doing? We're using past data, like the size of a house and the number of bedrooms, to predict the price of new houses. Our data. We have some sample data, where X is the input, house size in square feet and number of bedrooms, and Y is the output, house prices in thousands of dollars. For example, a house with 1,500 square feet and 3 bedrooms is priced at $300,000. Creating the model, we use linear regression, which is perfect for problems where you want to predict continuous values, like house prices. We create the model using linear regression. Training the model, we feed our data X and Y into the model using model.fit_xy. This is where the model learns the relationship between the size of the house, the number of bedrooms, and the price. Making predictions. Now let's predict the price of 2 new houses, one with 2,000 square feet and 3 bedrooms, and another with 3,000 square feet and 4 bedrooms. We pass this data into model.predict new houses, and the model gives us predicted prices. Output, the predicted prices are printed out, and they might look something like this. So, based on our model's predictions, a 2,000 square foot house with 3 bedrooms might cost around $350,000, and a 3,000 square foot house with 4 bedrooms might cost $600,000. Don't worry if this doesn't make sense yet. If this example feels a bit confusing or technical, don't stress. We're going to dive into this step by step later on and break it down in much more detail. By the end, it'll all start to click, and you'll be more comfortable with the code and concepts. This was just a quick introduction to give you a glimpse of what's possible with machine learning. By using a simple linear regression model to predict house prices, you can see how we start with data, train a model, and then use it to make predictions. But this is just scratching the surface. In the upcoming sessions, we'll be diving much deeper, starting with supervised learning. This is one of the core types of machine learning where the model learns from labeled data. We'll go step by step to explain concepts like how models learn from data, what features and labels mean, how algorithms like linear regression or classification models work, and how you can apply these techniques to solve different problems. We'll also walk through more code examples, explaining them in detail so everything makes sense. If this session felt a bit quick or technical, don't worry. We'll take the time to break everything down into manageable pieces so that you can fully understand and build your skills with confidence. This is just the start of your machine learning journey, and by the end, you'll be well equipped to tackle more complex problems. Stay tuned for the next session as we dive deeper into supervised learning and get ready to start building even more powerful models.